We are covering two key transportation topics for the FE Civil exam: signal timing using Webster's method and flexible pavement design using the AASHTO method. Both of these are found in the civil engineering section of your NCEES FE reference handbook. First, let's look at signal timing. The exam will test your ability to calculate the optimal cycle length for an intersection using Webster's formula. This formula is C0 equals 1.5 times L plus 5, all divided by the quantity 1 minus Y. Here, L is the total lost time for the entire cycle, in seconds. This is the time during each cycle when the intersection isn't effectively used, and it's typically given in the problem statement. Y is the sum of the critical flow ratios for each phase. A flow ratio is the actual traffic flow divided by the saturation flow, and the critical ratio is the highest one for a given phase. For an FE problem, you'll likely be given the critical flow ratios directly. For example, if the total lost time L is 10 seconds and the sum of critical flow ratios Y is 0.8, the optimal cycle length would be 1.5 times 10 plus 5, which is 20, divided by 1 minus 0.8, which is 0.2. This gives an optimal cycle length of 100 seconds. A major exam trap here involves the variable Y. In Webster's formula, Y is the sum of flow ratios. However, a separate formula in transportation engineering calculates the yellow interval time, and that variable is also often denoted as Y. This second formula is Y equals approach speed V divided by 2 times the deceleration rate A, plus the sum of intersection width W and vehicle length L, all divided by the approach speed V. The NCEES loves to create confusion with overloaded variables, so be absolutely certain which Y the problem is asking about. Now let's switch to pavement design. The FE Civil exam focuses on the AASHTO method for flexible pavements, specifically the structural number, or SN, equation. This equation relates the pavement's overall strength to its individual layers. The formula is SN equals a₁ times d₁, plus a₂ times d₂ times m₂, plus a₃ times d₃ times m₃. In this formula, A is the layer coefficient, representing material strength, D is the layer thickness in inches, and M is the drainage coefficient for the unbound base and subbase layers. A common exam question will provide the required total SN for a roadway, give you the properties and thicknesses for 2 of the layers, and ask you to calculate the required thickness for the 3rd layer. For instance, if a required SN is 4.5 and you have calculated the contributions from the asphalt surface and the subbase to be 2.0 and 1.0 respectively, you would know that the base layer must divide the remaining SN of 1.5. You would then use the term a₂D₂m₂ equals 1.5 and solve for the unknown thickness d₂. The most common mistake is forgetting to include the M drainage coefficients for the base and subbase layers, as the surface layer's M is assumed to be 1. To help remember these concepts, use this mental shortcut. Don't let the 2 Y's get you yelling. One is for cycle yield, the other for traffic yoke. And for pavement, remember SAD MD for the layers. Surface is just A times D, but the base and subbase are MAD, M times A times D. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.